This is a revision video on forces and braking. Stopping distance, the distance it requires to bring a vehicle to a stop, is equal to the thinking distance plus the braking distance. And the thinking distance is how far the car is travelling whilst the driver is thinking about stopping. The braking distance is how far the car is travelling whilst the driver is braking the car, whilst the car is decelerating. So the thinking distance depends on driver's reaction time. And the braking distance depends on the car and the car's deceleration. Driver's reaction times are typically between 0.2 to 0.9 seconds. So generally, the more tired you are, the greater the value of your reaction time. The older you are, the higher your reaction time. The younger you are, the quicker your reaction time. The more alert you are, the quicker the reaction time. And we can measure reaction times, or we can obtain them using computers, or we can use experiments like the dropping a ruler reaction time experiment in biology. And computers are generally more accurate, have a greater resolution, and they don't require two sets of reaction times. So for example, you see a green light on the screen, you click once, just reaction time, whereas dropping a ruler requires you to react to drop and then react to catch. So, going back to the stopping distance, if the thinking distance is increased, the stopping distance increases. If the braking distance is increased, the stopping distance is increased. If the thinking distance and the braking distance have increased, the stopping distance increases even more. So, any factor that increases the thinking distance will increase the stopping distance. Any factor that increases the braking distance will also increase the stopping distance. So let's talk about these factors now. And we can quite simply break it down into factors that affect the thinking, the driver, and factors that affect the car, the braking distance. So that's the way I always look at it. If it's affecting the driver, it's affecting the thinking distance. So for example, the driver could be drinking alcohol or having drunk alcohol, drinking alcohol. What that's going to do is going to decrease the reaction time, it's going to slow down the reaction time, which is going to increase stopping distance. Drinking alcohol, taking drugs, taking some medications, they all increase reaction time. So it slows the reaction time down. Other things that can affect the thinking distance are things such as distractions in the car, such as babies crying, people talking, radio on loud, mobile phones. That's why using a mobile phone when driving is illegal. But distractions and the speed of the vehicle, and people often forget this one. The greater the speed, the greater the thinking distance. So what factors affect the braking distance? So the braking is all about the car and the road. That's the way I look at it. And anything that affects the car, such as condition of the brakes or the tyres, the condition of the road. If it's in poor condition, you're not going to stop as easily. If it's wet, snowy, or icy road, you're not going to stop as easily. You can't just say the weather though, because wind, sun doesn't have any effect on the braking distance. Again, speed has an impact on the braking distance. The faster you're going, the greater the braking distance. the greater the total stopping distance. So anything to do with the brakes of the tyres or the road, or icy, snowy, wet conditions. Could be things like going downhill. Going downhill, you've got gravitational potential energy as well, so it's going to require a greater distance to brake. If there's oil on the road, it's going to be slippery, it's going to require a greater braking distance to brake. It's going to require a longer time. So don't think these lists are limited to these. There are many others, but we could be here all day going through absolutely anything that affects them. Just stop and have a little think for yourself. Don't forget, if it's affecting the driver, it's increasing the reaction time, which increases the thinking distance, which increases the stopping distance. So you can link the reaction time to the thinking distance and the stopping distance, and you can make your answer more detailed. So when we brake, and this is for higher tier only, when we brake, we are doing work done. We're doing work. Well, braking equals work done. We're doing work on the brakes, and that slows the car down. If we're slowing the car down, that's decreasing the kinetic energy of the car. It's decreasing the kinetic energy, but we're getting friction of the brakes. We get friction of the brakes, and friction leads to an increase in thermal energy. So increase of thermal energy. And if the car's travelling faster, we need a greater force. We need a greater force. And if we've got a greater force, we get a larger deceleration. And large decelerations are dangerous because if we have a large deceleration, we may lose control. And also the brakes may overheat. So or the brakes may overheat. So that's it for combined science. Triple physicists, keep watching because there's a bit more for you. So this is triple only. And triple only, you need to be able to estimate the forces and braking distances. So to do this, we can work out kinetic energy. For example, if we've got a car of mass 500 kilos traveling at 20 meters per second, we can calculate kinetic energy. EK equals half times mass times the speed squared, and that equals half times 500, which equals times 20 squared. Trusty calculator, 0.5 times 500 times 20 squared. And that gives us a kinetic energy of 100,000 joules. Don't forget, energy is work done. So work done equals force times distance, or work done equals force times distance if you're using AQA. So we can now put this 100,000 kinetic energy into our work done. And let's do two different examples. Let's do a gentle force braking. Let's do 500 newtons first. So work done, 100,000, and our force is 500 times D. Opposite of times 500 is divide by 500. Again, use our trusty calculator. So that's going to stop in 200 meters. And over there, it's exactly the same calculation, same rearrangement, you still get the answer, it's just S for AQA. Now let's do a more forceful deceleration. Let's now use 2,500 newtons of force. Our kinetic energy of the car was 100,000 equals 2,500 times by our distance. That 2,500 of braking force, opposite times 2,500 is divided, so 100,000 divided by 2,500 equals D. Trusty calculator. Which equals 40 meters. So that car's come to a stop in a much shorter distance. So if we want to stop in a shorter distance, we need to apply a greater force.